So hyperbolas is the last type of conic sections we need to discuss. This will be a two-part lesson. So the first part we'll be looking at how to graph from HK form, looking at a graph, write an equation, and then how to write the equation in HK form when we're just given the general or standard form. The centers today, though, will always be at the origin. The next lesson, I'll probably post in 2 more days. We'll be over when the centers are not at the origin. So today we're just going to start off pretty basic. Not a lot of problems to do for the assignment, but let's take a look here at the equations of a hyperbola, looking at them in HK form, being able to identify the center. And then what we're going to need here, make sure you guys have rulers when you go to draw these. It'll be the most accurate. We'll have the slopes of the asymptotes, and I'll explain what those are once we look at a couple of examples. But there's 2 directions for hyperbolas. As we first mentioned way back when we were going over the types of conic sections, so just to write these out. First we have what I consider just the direction here. Remember, hyperbolas always come as a pair, so we'll call these like an east-west or sideways direction. And then we also have when one opens up and the other one opens down, so we'll call this a north-south. All right, so these equations in HK form are going to look very similar to that of the ellipses that we just talked about. But if you remember, when we go to identify the types of conic sections, hyperbolas will always have an x squared and a y squared. When on the same side, one coefficient has to be positive, the other one's going to be negative, so that's going to be our difference here. So when we go to look at these, we're still going to have an x minus h squared over an a squared, but now instead of there being a plus sign in the middle, there's going to be a minus sign, and then we have y minus k squared over b squared, and it equals 1. So the only difference right now is going to be the minus sign. However, when we go to look at a north-south, remember with an ellipse that a squared was larger? Well, that's not the case here. A squared and b squared, our denominators stay put. It's our numerators that change. So when we're looking at a north-south, it's the y that goes first. So we'll have a y minus k squared first. It's still over a squared. So I emphasize again, a squared and b squared, we're not considering which one's larger. They stay in the same place. So a squared will always be the first denominator, but it's the numerators that are now changing. And then that's going to equal a 1. So our center still comes from HK. We just have to be aware of now when the y is first, so is the k. But we always want to put the h value first for the center, and then the k value will go second. Now, when we talk about slopes of asymptotes, like I said, when we start to graph them, you'll get the picture of what these, or how these apply. So the slopes of the asymptotes here, we'll write this as m is going to equal plus or minus b over a. So where a and b with an ellipse helped us to determine like a radius, a different radius for each direction, the b and the a here are going to help give us guidelines to drawing the hyperbolas. Over for north-south, slopes of the asymptotes, will be plus or minus a over b. And I'm going to keep going back over this, but remember, slope is the change in y's over the change in x's, or rise over run. So notice where this y is here in the east-west facing one. Notice how b is underneath it. So wherever the y is, that b in this case is going to be our rise over our run. The a is underneath the x. But if you take a look at the north-south, notice where the y is and what's underneath it. It's a over b. So it's wherever that y is, because remember, it's always change in y's over change in x's. So we look to see what's underneath. When it's north-south, the a is underneath the y, so it's plus or minus a over b. The east-west, the b is underneath the y, so this changes. It's plus or minus b over a. We're not really going to talk too much about the vertices in this case as far as how to write them out, but when we go to graph them, we will be stating them. And it's a little different here. The vertices are only where the hyperbolas touch. We'll kind of take a look at. We're going to draw a rectangle in the asymptote, so we'll write the vertices in after we graph them. All right, so let's take a look at example 1. Please copy it down. Again, if you don't have graph paper, please make sure you're using a ruler or some sort of straight edge to be able to draw these as neat as possible. We're going to have to draw a rectangle and then 2 diagonal lines to help us graph these the best. As far as actually drawing in the hyperbolas, we're just going to draw them in as best we can. All right, so if we look at this, first thing we want to identify is our center. If you notice in our numerator, there's nothing inside parentheses along with the x and the y, and as I mentioned before, our center right now is going to be at 0, 0. Notice that x squared comes first, so this is a sideways hyperbola, so this is going to be an east-west facing hyperbola. And then a is always the first denominator, so a squared is 4, which makes a 2, and then b squared is 25, so b is 5. Now the slopes of the asymptotes, I'm just going to write this as m for slope, is going to be plus or minus. Now remember, it's what's ever underneath the y, so it's going to be plus or minus the 5 over 2. So we're taking b over a, so it's plus or minus 5 over 2. So what we want to do here is go ahead and plot our center at 0, 0. I want to count up 5, 2 to the right, up 5, 2 to the left, down 5, 2 to the right, and then down 5, 2 to the left. What I'm going to do now is draw a rectangle. I'm going to cheat a little bit here and use this. So we're going to go ahead and draw this rectangle. Or make it a different color. All right. So again, we use our slope to make these 4 points. So again, going plus 5 halves means we're going up 5, 2 to the right, or down 5, 2 to the left. Negative 5 halves, we're going up 5, 2 to the left, or down 5, 2 to the right. Next, what we want to do is draw diagonals. And we want to extend them. It's the extended part is where we're going to draw our hyperbola. So again, I'm going to go down another 5 over 2. Make sure that you draw these diagonals going through the corners of the rectangle and beyond. And then the same thing on the other side. So we get these 2 diagonals. Now because this is supposed to be an east-west, I'll still use green, an east-west hyperbola, it's on the left and the right side of the rectangle. Right in the middle is where I want to draw these 2 points. These are the vertices. So my hyperbola is going to, guidelines here to go by, it's going to come very close to this diagonal, and then it can't go through the rectangle, so it's going to turn a little bit, go through this vertex, and then continue this way. So again, try to draw it as best you can. The larger ones are a lot tougher to kind of draw. So we have this wide curve coming through, just touching right there, and continuing this way. So we have one vertex over here at 2, 0. The other one is going to be at negative 2, 0. And we'll continue the same way. Very close. Don't draw these too quickly. They have to be very close to the diagonal and just touch right there at the vertex and carry on this way. Again, good way to check is to graph this on your calculator or on Desmos, but that's what we should be getting. And that's really all there is to it. So we have the direction, we draw a rectangle. These blue diagonals are the asymptotes, so we were able to get the slopes of the asymptotes and draw them in this way. All right, taking a look at example 2, we have y squared over 64. Again, notice the minus sign, x squared over 9 equals 1. Our center, again, since there's nothing up here with the x and the y, our center, again, is going to be at 0, 0. Again, a squared is always, in this case, for hyperbolas, the first denominator. So a squared is 64, making a 8. B squared is 9, so b is 3. The slopes of our asymptotes here, plus or minus, we always go with what's underneath the y. So in this case, it's going to be a over b, so 8 over 3. And then we could plot our center at 0, 0. I'm going to count up 8 over 3, down 8 over 3, and then up 8, 3 in the other direction. Same thing down here. And we didn't go over what direction this is. Notice the y squared comes first, so this is going to be a north-south direction for our hyperbola. Let's go ahead and draw on our rectangle. Right. Maybe I'll make this a different color. I don't want to change that. That's good enough. Makes it a different color now. All right, so we're going to go ahead and draw in our diagonals. As best we can here. Because this will be north-south, it is going to run a little bit off of our coordinate plane. All right, so here are the asymptotes. Best we can get them. And then at the very top, because this is a north-south, here are vertices. So we have one vertex up here at 0, 8, and then the other one down here at 0, -8. All right, so these are a little bit closer together. It's a little bit easier to draw the hyperbola curve. So again, I want to start very close to this asymptote, turn to go right through the vertex, and then back up the other side. And then same thing at the very bottom, stay very close to this, then we turn to go through it, and graphing it that way. Like I said, don't draw it too quickly. Make sure it's getting very close to the asymptotes and it touches right there at the vertex. All right, so two very basic examples to get started with identifying the center, slopes of the asymptotes, the direction of the hyperbola, and putting all those pieces together to graph. All right, for this next one, we're going to get this in vertex form. Again, our centers are focused right here at 0, 0. So again, take a look here. We have to get the x squared and y squared on the same side. So in doing that, we'll have 9x squared minus 25y squared. We'll leave the 225 on the other side. So notice we have an x squared and a y squared, but notice the 9's positive and then the 25 is negative. So what I want to do now is divide everything up here by 225. Now, actually, 9 times 25 is 225. Anytime I multiply by 25, I think of quarters. So if you have 9 quarters, you would have $2.25. So that's a quick way to always check that. So we're going to end up getting x squared over 25 minus y squared over 9 is equal to 1. Go ahead and pause this for a second and see if you can identify all the pieces that we just looked at in our first couple examples, meaning the center, the slopes of the asymptotes as well, and the direction. All right, so if you were saying, as I mentioned before, the centers are all going to be 0, 0, so that matches here. Since x squared is first, this is going to be an east-west facing hyperbola, so it opens to the sides. A squared, again, is always our first denominator, so a squared equals 25, so a is 5. B squared is 9, so b is 3. Slopes of the asymptotes are going to be plus or minus. Wherever that y is, that's the number that goes up first, or the square root of this number. So it's going to be b over a, so 3 over 5. So we go ahead and plot our center. I'm going to count up 3, 5 to the right, up 3, 5 to the left, down 3, 5 to the left, and down 3, 5 to the right. So there's my rectangle. Next, we want to draw in the asymptotes. Again, make sure you go through the vertices of the rectangle. All right, so now when we go to graph this, again, it's east-west. Our vertices here are going to be in the middle of both sides. So here we have a vertex at 5, 0, and then a vertex at -5, 0. Again, we want to hug the asymptote pretty closely here. Turn, go through the vertex as best we can. And we get something like this. And again, on the other side, stay very close to that diagonal. Go through our vertex. All right. So again, as always, let me know if you guys have any questions over these first few examples. Our last two, we're going to be given the graph, and then we have to write the equation for it. So let's take a look at those. All right, if you want to pause the video right now, just count. Notice the centers, I will point this out, are at 0, 0, but count for the slopes of each asymptote and go ahead and write that out first. All right, so our center for this first one, I'll call this just A and B. So looking at A, again, our center's at 0, 0. If you notice, if I start here at the center and count up, we're going up 5 and over 3. So the slopes of our asymptotes are plus or minus 5 over 3. This is an east-west facing hyperbola. So if we go to write our equation, I know I'm going to have two fractions separated by a minus sign, and it's going to equal 1. Since this is east-west, I'm going to have x squared first, y squared second. Now remember, the numerator of our slope, if we square it, that's going to go under where y is. So this means this is plus or minus a b over a. So 5 squared is going to go second to become a 25. And then 3 squared will go first, which will be the 9. And then there's our equation. So you just have to figure out. So this tells us b is 5. So b squared is 25. And that goes under the y. A is 3. So a squared is 9. And that goes in our first denominator. So this right here is our equation. Again, you can check on Desmos and see if you get the same result. All right, for b, again, our center is at 0, 0. Our slope is going to be plus or minus. If we count from the center, we're counting up 2 over 3. One thing I will point out, if the slopes happen to be able to be simplified, we don't want to do that because then that's going to change the size of our rectangle. So if we happen to get a slope of 3 over 3, we want to leave it like that because we definitely have to count up 3 over 3 in order to draw that the size of our rectangle. So in this case, slopes do not simplify. All right, this is north-south. So if we go to write out our equation, we're going to have two fractions being subtracted equals 1. North-south means y squared is going to go first, then x squared. So this 2 is now going to go under the y. So this means a is 2, so a squared is 4. So we'll have a 4 in our first denominator. And then b is going to be the 3, so b squared is going to be 9, and that's going to go for our second denominator. So here is our equation of our second graph. So these are the items we're looking for, the center and the slopes of the asymptotes. With the ellipses, like I said, we were using A and B to help us find the length of the major and minor axes, or to kind of show the radius of each side that we were looking at. All right, so your assignment, I have this at the very end, so I'll go through each page. You only have 3 problems. Like I said, it's not a lot, but just take your time with it because it's very easy because of how similar it looks to the ellipses to get things confused, so please take your time. In about 2 more days, I will give you the second. I'll go over the answers to these 3 problems, and then I'll give you the second day of lessons on hyperbolas. So I'm also going to post this as a PDF as well, the worksheet. All right, but just looking, you have 1, 2, and 6. I'm just going to talk about those problems. So for number 1, if you're able to print this out, that's great. If not, please, again, make sure you're drawing the graphs as neat as possible. So identify the center. After you graph it, you could identify the vertices and then the slopes of the asymptotes. 2 is very similar. On the next page, you're skipping 3 and 4 for right now. There was no number 5 that I typed on here, so that's why you're just going to 6. Write this in HK form. That's all you have to do. So not a lot. Like I said, get caught up with your other assignments as well. I will post this as a separate PDF, but you're just doing 1, 2, and 6.